So now we're going to look at the thermocouple data, and we're going to look at what happens when we do a linear fit and decide that the data was not quite linear and maybe had a little bit of curvature to it. So we've seen already how we go about adding trend lines, and we're going to add a trend line to this data here. Again, we go to Chart Design, Add Chart Element. This is where we add pieces to the graph. We can add a, whoops, not a legend, a trend line. We can add a linear trend line with the display equation shown. And then let's go ahead and add another trend line to see whether that looks any better to our eye. We're going to add a, uh, a polynomial of order 2, that is to say a quadratic. We're going to show that equation as well. And we can see that the quadratic does go through the points a little bit better. And if I were to make a residual plot, which I did for the enzyme kinetics with regard to that linear trend line, I'm not going to take time to do that here, we would see that there was a bit of a trend in the residuals, that the points were a little high from the line over there and a little low here and a little high again on this side. And that's the curvature that this slight quadratic term is picking up. So again, for cheap, doing these trend lines, we get the value of these three fitting coefficients. But again, to find out the error bars in those coefficients is a bit of an ordeal in Excel. And so that's what I'm going to demonstrate now. As before, let me show you in the finished product what's involved in that, and then I will show you how to construct this. So it turns out that what we have to do in the case where we're fitting more than one function in the linear least squares fit to the data is we have to make columns for the functions that we are I'm not saying this well. What we're doing is we're fitting to constant plus something times v plus something times v squared. And what we have to do is prepare columns for v and for v squared in order to use LINEST in this case. This is just somewhat involved, and you're just going to have to bear with me. So we're going to make columns like this, and this one's just a dead copy of this, but this is a column which is the square of these numbers, and I just grouped them together and labeled them like this to make things clearer. And so if I go back over to the start page, then I'll just reproduce this by typing a caption, fitting functions, and then v, and then v squared. And the formulas that I need here are equals just a dead copy, and then equals this thing squared, and then I just take this and copy it all the way down, and I've got my two tables that I need for doing this fitting operation. So as before, when I did the LINEST example, I'm just going to copy the headers that remind me what it is I'm about to get. I could type this in if I could remember what it was that I needed to type. It's just a reminder of what's going to come out of this little magical operation, where we highlight this little patch of cells, type in LINEST, and hold our tongue in a certain way as we hit Control-Shift-Return to get it all to work. So as before, the things that we're getting here are the fitted values, the error bars, and some stuff we don't care about, which is 5 rows deep, but now it's 3 columns wide. So why 3 columns wide is because we're fitting 3 numbers: the intercept, the coefficient of the v, and the coefficient of the v square. And these tables here are the tables of the fitting functions, v and v squared. This thing is a linear combination of these three things. So in short, the little patch of numbers that we need to highlight for this to work is 5 by 3 instead of 5 by 2 as it was before. As before, we type in with this whole thing highlighted. So this stuff's all gray. I do not, repeat, do not click into this box here. Just start typing after you've highlighted this range of cells equals LINEST parenthesis, and now it prompts me for the stuff that I'm supposed to supply, the known y's. Okay, what are those? Well, those are the temperature values, the measured things, the things that are on the vertical axis. Okay, comma. The known x's, well now that's this stuff all together. And that's why I put these two columns together, just so I could highlight this whole range all in one go. And then, as before, for some reason that I don't know, you type true, comma, well, true, comma, true, close parenthesis, don't hit return, hold down Command, Shift, and then hit return with your tongue held just so, and it fills in the numbers that you're looking for. And if we look in this table, we recognize the intercept, 296, of the quadratic fit, the slope of that is the coefficient of the v is the very first one here. That's 8.87, and that's this thing here. Wait a minute, something's messed up. M2, M1B. I don't know why those came out in that order. This seems to be M2, M1B, not M1, M2B, so this is wrong. Okay, well, anyway, it's a good thing we had this up here because then we can identify which of these silly numbers is the one that we wanted. This is the coefficient of the quadratic term. This is the coefficient of the linear term. That's the intercept. And this is the error bar on that thing, and this is the error bar on that, and this the error bar on that. And those were the numbers we really wanted. Okay, so from this somewhat Byzantine procedure, you get these confidence intervals, error bars on the fit.